Hello and welcome to the first of our series of educational videos on the technical evaluation of autonomous mobile robot projects. Today, we're going to dive into the essential steps and considerations involved in assessing the feasibility and technical aspects of implementing an AMR system. Whether you're new to the world of AMRs or looking to build your knowledge, this video should guide you through the intricate details of evaluating an AMR project. Joining me today is Rishabh Aurora, team lead for application engineering at Mobile Industrial Robots, which we better know as AMR. Thank you for joining us today.
Thank you for having me.
So let's just jump right in. We're going to start out with what are the key factors to consider when assessing the technical feasibility of implementing an AMR system?
There are a few different factors to consider, starting with, what kind of payload you want to move with the robot and selecting an appropriate robot accordingly based on the payload, the size of the payload, and then, of course, the correct top module. So if you'll be moving a pallet, then choose a pallet lift, for example, or if you're moving a cart, then a hook, for example. Other things in plant layout, the routes that the robots would be taking, if there's going to be enough space for the robots to move through those routes, and then frequency of missions. Other things, traffic conditions, such as interaction with forklifts, other AGVs or AMRs that may already be in a facility. Integration to existing systems such as warehouse management systems or ERP systems. Then, user interaction, how are the operators going to interact with the AMRs on the floor? Would it be through a dashboard, push buttons, tablets, or would it be all integrated into the warehouse management systems? Wi-Fi analysis is a very important part as well, just to make sure that the robots stay connected to the fleet throughout the plant. Environmental conditions such as the floor condition, make sure the floor is level or is in good shape for the robot to travel. If there's going to be enough static objects for localization of the robots or AMRs, and then temperature conditions and other things that relate to the environment. Then also making sure the roles and responsibilities are defined for people on the floor, for engineers or production people and maintenance people.
Great. Lot to consider. It's a big undertaking, and doing your homework first is definitely essential. So can you explain the process of selecting the right sensors and the software that an AMR project would require?
So AMRs do come with a lot of sensors on board, such as laser scanners and 3D cameras. There are external sensors for integration that can be used, such as depending on the application. So let's say if you want to detect pallets on a pallet stand, you can use sensors for that. It could be laser sensors or just object sensors. And then, overhead sensors for tracking carts, sensors on conveyors to confirm load transfer. So if you're, for example, moving a load on the robot with a conveyor top module and then interacting with a conveyor station, you would want to have sensors on both ends to make sure the handshaking is done properly and loads safe before the robot moves away after dropping off the load. In terms of software, there could be, of course, you would want to have fleet software to control the robots, and so you don't have to deal with individual robots. And also, for integration, there could be different software that could be used depending on the skill sets or existing infrastructure. There are many different softwares that could be used, like PLC softwares or WMS systems, as I mentioned, or Ignition for integrations. For analytical purposes, programming scripts such as C++ or Python could be used, or manufacturer-supplied software such as AMR Analytics that AMR provides, for example, that could be used. So depending on the need for integration, different software could be used.
Right. So speaking of that integration, how do you evaluate the integration of a system with existing infrastructures and existing workflows?
Yeah. So, again, some of that would be, warehouse management systems, and then see if the AMR system can be integrated with that or not, if a new system would be needed. Other thing would be, to check if there are going to be any challenges related to navigation, user interaction, traffic management, and then also conduct a proof of concept. Very important part, to make sure that the robot's going to be able to work, and if there's going to be any changes that are needed, in the system as you determine that during the proof of concept.
Okay. So when it comes to the risk assessment of doing these projects, how do you conduct that? And what are the critical safety considerations?
So depending on different applications, it could be different, but overall, you need to make sure that you're following the correct ANSI standards. And if you're using any custom top modules, make sure they comply with those standards as well. And then documenting any residual risks if there are any. And then also, just conducting brake tests, for example, on the floor, where you would drive the robot at different speeds and using foam blocks or something to make sure the robot can stop safely with different loads at different speeds in different areas. If the floor is going to be different in different areas, then you would want to conduct those tests in all different areas of the plant. So some of those things are used to do the risk assessment.
Okay. And let's, of course, talk about ROI. I mean, how do we determine the ROI? What factors should be included in the cost benefit analysis if somebody wants to put an AMR system into their plant?
So there's two factors that typically our customers we've seen that they use. One, of course, is how much of the labor can they redeploy towards more productive tasks, such as actually producing parts rather than doing moving 20,000 steps in a day. So they evaluate the cost of the robots and integration against how much more productive that they can become by redeploying the people that they have, because a lot of people struggle with labor shortages. So one is that. The other one is safety as well. That you can't really put a cost to safety, because a lot of companies want to reduce the risk of forklift accidents, and that's why a lot of customers deploy AMRs as they're safer over forklifts. So that is a big advantage as well in terms of return on investment.
Oh, great. So this was a very quick overview of what people should consider when they're deciding to implement an AMR system in their company. So as we wrap this up today, we hope that you, our audience, has gained some insight into the technical evaluation process. And I want to thank you, Rishabh, for reminding us that thorough assessment and planning are key to the successful implementation of AMRs. And we want you to stay tuned for more in-depth discussions on autonomous mobile robotics and stay curious about the possibilities of this cutting-edge technology.